All right, so we've been doing prisms and cylinders. Today we're going to move on to pyramids and cones. So with pyramids, we are only going to do regular pyramids for the majority of our problems. So a regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. When you think of a pyramid, you typically think of a square pyramid, and all of the lateral faces are the same size, right? That's going to be true for all of our pyramids. The lateral faces are going to be the same size, okay? There are a couple of things that you need to know. The altitude, or the height of the pyramid, is a segment from the vertex perpendicular to the base. So that is, if you were inside a hollow pyramid and you drop something, the path that it would follow, or like a tent pole in the middle that goes straight down perpendicular to the ground. So the altitude or the height, we will use both interchangeably, is this segment right here in the middle. The slant height also goes to the vertex, but it goes from the vertex down perpendicular to the base, but it goes to the midpoint of the base. It's called the slant height because if you're looking at the pyramid sitting on its base, it slants over. Both of them are going to be important to us. It's important that you do not confuse the two. The slant height is always longer than the height, no matter what. If you think about it, if you're at the vertex of the pyramid, what is the shortest distance to the ground? Yeah, perpendicular to the ground. It's not to slide down one of the faces. Okay? All right, so for a regular pyramid or a cone, here are our formulas. The lateral area is 1/2 perimeter times slant height. Yes?
Does the slant height, I think you might have said it, but I'm not sure because I didn't really understand. If this is the face, does the slant height, because it goes to the vertex?
The slant height is the height of the face. So like if you were...
so the slant height, like, is the face?
It's on the face.
It doesn't start in the vertex?
It does start at the vertex.
So wouldn't it, like, go off the face?
No.
Like,
hang on a second.
oh, they're together.
So this is the slant height.
Okay.
And the height is in the middle.
Okay.
Okay? All right. So the formulas for lateral area, very similar. 1/2 perimeter of the base times the slant height. Why is it 1/2?
Because if you doubled it, it would be a square.
What kind of a lateral face does a pyramid have? It's a triangle. The lateral face of a pyramid is a triangle. What's the area formula for a triangle? 1/2 base times height. That's why it's got a 1/2 in it.
For lateral area of a pyramid, do we ever have to do like...
It's the sum of the areas of these triangles. Okay? And then it works the same way for a cone, except it's circumference. And then the surface area is the lateral area plus the area of just one base, as opposed to cylinders and prisms that had two bases. All right, so let's do this one. Find the lateral area and the surface area for each regular pyramid or cone. So for this one, I always start with the base, just like I do for the prisms and cylinders. So the perimeter of the base, just going to be 4 times 12 is 48. The area of the base, it's just going to be 12 times 12 is 144. The lateral area will be 1/2 the perimeter of the base times the slant height. So it's just like 1/2 base times height, except it's the perimeter all the way around the base of the solid, and it's the height of the lateral face, which is the slant height. So that's going to be 1/2 of 48 times 18. See, that's 360 plus 72 is 432, if I did that right in my head, square meters. And then the surface area is the lateral area plus the area of just the one base. So it's 432 plus 144 is 576 square meters. Any questions about that? All right, moving on then. A regular hexagonal pyramid with base edge length 6 centimeters and slant height 10 centimeters. All right, so again, I will start with the base. It's a hexagon. The base edges are all 6. So the perimeter of the base, well, is 36. The area of the base, for a regular polygon of any kind, we can do 1/2 the apothem times the perimeter. And we have to take a little bit of time out to find the apothem. Hopefully by now, you have memorized at least some of these, especially the hexagons, the triangles, the squares, that the central angle here is 60, so this angle is 30. So this is 3, and the apothem is 3 square roots of 3. And that's 54 square roots of 3. So now the lateral area is 1/2 base times height. It's the perimeter of the base, and the height of the triangle is called the slant height. So that's 1/2 of 36 times 10 is 180 square centimeters. And the surface area, so lateral area plus, we just have one base. So it's 180 plus 54 square roots of 3. We'll put that all in parentheses, square centimeters.
I thought surface area was cubed.
Why would centimeters be cubed? This is area.
Which one is cubed then?
Volume.
Oh,
In volume, we're seeing how many cubes it takes to fill the object. In area, we're seeing how many squares it takes to cover the object. Okay? All right. So for this next one, we're given the radius of the base, and what is this 12? The height. But we're not given the slant height. Now hopefully you can look at this and just go, oh, the slant height is 13 feet. If not, you can do the Pythagorean theorem to show that. I'll still work with the base first. The circumference of the base is going to be 2 times pi times 5 is 10 pi. The area of the base would be pi times 5 squared is 25 pi. So the lateral area is 1/2 circumference of the base times the slant height. And again, it's the slant height because that's the height of the lateral face. So it'll be 1/2 of 10 pi times 13 is 65 pi square feet. The surface area will be the lateral area plus, I've just got one base. So that's 65 pi plus 25 pi is 90 pi square feet. Okay, any questions about that? All right. So I'm going to cut to the chase on this one and show you that there's a really fast way to do it as opposed to having to go through a lot of steps. Okay, so area is what kind of units? Square units. If I triple all of the units, what do you think I will do to the square units? I'm sorry? Nope. Okay, so if I found the surface area of this figure and then tripled the radius and the slant height, I'm making this cone 3 times larger in every dimension.
It's still square.
Wait. I don't know what you're talking about flat.
I thought if you made the circumference bigger.
And made the slant height bigger, I'm tripling every dimension.
It would still be square.
Right? So it's 3 times taller, 3 times wider. Everything's 3 times bigger. Are you with me? Okay. What do you think I'm going to do to the surface area? I'm going to give you another hint. It's in square units.
Square it.
Yeah, you just square it. You guys aren't convinced. We're going to have to do this. Sorry, but we're going to have to. All right. So, for this one, circumference, 2 times pi times 3 is 6 pi. I'm going to go really fast through this. The area of the base, pi times 3 squared is 9 pi. The lateral area, 1/2 circumference times the slant height. That's 1/2 of 6 pi times 5, 15 pi. Surface area is the lateral area plus the area of the base. 15 pi plus 9 pi is 24 pi. Now I make a new cone. This new cone is way a lot bigger. How many times bigger? 3 times bigger. So what is the new radius? 9. What's the new slant height? 15. All right, let's find the circumference. The new circumference will be 2 times pi times 9 will be 18 pi. How is that different than the old circumference?
Times 3.
Yeah, it's 3 times bigger. Circumference is a linear, just one unit, right? Then the area of the base would be pi times 9 squared, be 81 pi. What do I have to multiply 9 pi to get 81 pi? 9. Okay. Let's go on. 1/2 circumference times the slant height. So that's 1/2 of 18 pi times 15. 9 times 15 is 90 plus another 45 is 135 pi. Is this 3 times bigger than this? No. What's 3 squared? 15 times 9 is 135. Let's go on. Surface area. So lateral area plus the area of the base. So that'll be 135 pi plus 81 pi. That's 216 pi. 216 pi divided by 24 pi is 9. Whatever I do to the units, the area, since it's square units, I will square whatever I did to the original units. I multiplied the original units by 3, right? I have so many blank faces right now. I don't understand.
I'm just confused.
About what?
What do you? You're saying that because the base is square?
No, I'm not saying that. I'm saying because what are the units in area?
So square units, so it gets square.
So whatever we did to the units, we multiplied those by 3. What do we do to the square units?
Square.
What's 3 squared? We're going to multiply those by 9. I'm still getting,
It doesn't. I'm just confused.
okay?
Easier.
So if I multiply by 3, and that's for feet, then for square feet, I should multiply by 3 squared. Because it's square feet. I'm just squaring both sides of this. And that would be times 9. What if I was to multiply every unit by 5? What would I multiply the area by? 25. Because 5 squared is 25.
I think that's.
How does it make it like faster than doing it the other way?
If the way I would do this, I would go, oh, I multiplied all the units by 3, the area is multiplied by 9. I'm done with the problem. I have done 0 work.
So just the area gets squared because it's.
The area gets whatever happened to the units, you square that to find out what happens to the area.
So it's just the area that gets squared.
What do you mean the area gets squared?
Like the new area of the base.
I'm not, no. This new area is 9 times bigger than the old area. Right? This new lateral area is 9 times bigger than the old lateral area. This new surface area is 9 times bigger than the old surface area. Every one of them is 9 times bigger because it's area, and what we did to the lengths was multiply by 3. Square 3, and you get
That makes sense.
9. Yes.
So if you were multiplying it by 4, if you were making it bigger times 4, you would multiply everything by 16.
Exactly.
So you do 24 pi times 16, 15 pi times 16.
Correct.
Okay.
What now? Let's take it just a step further real quick. What would you do to the volume?
Cube it.
You cube whatever you did. So let's say you multiplied everything by 2. Your new volume would be 2 times 2 times 2, which is 8. Your new volume would be 8 times larger than your original one.
So in order to find the volume, you multiply it by 8.
Yep. All right. Let's see if we can get through at least part of this last one. What time does y'all's bell ring?
38.
38. I can do that. All right. So for surface area, again, just like it was with prisms and cylinders, you can't just do the surface area of one plus or minus the surface area of the other. That's never going to work. But let's think about the surfaces that we can touch on this one. What part of the cone can we touch?
The lateral.
The lateral area. So we need the lateral area of the cone. What part of the cylinder can we touch? And what else?
One base.
And one base. So this is how you go through and figure out what it is that you want to do. There is another way to do this. I don't like it because students try to start memorizing it as a formula. You could do the surface area of the cone plus the surface area of the cylinder minus 2 times the area of the base because those two bases are glued together. That makes sense? You suddenly can't touch either one of those.
Why don't you like it?
Because students try to make a formula out of it, and it works for this one,
But
but
it doesn't work.
it doesn't work all the time. So the lateral area for the cone, we're going to do 1/2 the circumference of the base times the slant height, plus the lateral area of the cylinder will be the area of the base times the height, plus the area of the base. It's going to be pi times 28 squared. So let's see, this is going to be 1/2 of the circumference will be 56 pi. And those dirty, rotten scoundrels, they didn't give us the slant height. Well, we can find it. We know that this is 28, and we know that this is 45. How do I know that? Because halfway up, this part was 45 and the whole thing is 90. You're like, is that going to come out to be nice? Well, where is my calculator? I had 2. Yes, I had another one up here though. So if I do the Pythagorean theorem with 45 squared plus 28 squared, and then take the square root, 53. It's a Pythagorean triple you never even heard of. Plus, the area of the base is going to be 28 squared pi, so it's 784 pi, times the height of the cylinder is 45, plus the area of the base of the cylinder is 784 pi. And you get a whopping 37,548 pi square centimeters. All right. Your assignment is in the book. It won't be due till Monday.
Mr. Davis,
Yes, sir.
why does pi go on forever?
There are a lot of numbers that go on forever.